All right, today is about concavity. What is concavity? Well, that's the downward or upward cup type thing. The cup is pouring out, so that's concave down. The cup is facing up, so that's concave up. Okay? Where does it change from concave up to concave down? About there, about there, about there, about there, about there. Okay? That's where it changes. Where it changes, where these green dots are called points of inflection. How do you find a point of inflection? Well, that's where the second derivative of the function is equal to 0. Okay? So then we're going to do a little review here. Here's a max, here's a min, here's a max, here's a min, here's a max, here's a min. In general, it's about halfway in between. Most of the time, it's halfway in between. Not absolutely, but it's where the second derivative equals 0. So the pink points are maxes and mins, and that's where the first derivative of the function is equal to 0. So when you find where the first derivative is equal to 0, that's going to be a max or a min. Where you have the second derivative equal to 0, that's going to be a point of inflection where it changes concavity. Okay? So then you're going to test somewhere in between the points of inflection. And when you do a test, if you take the second derivative, and if it's positive, then it's concave up. And if the second derivative is negative, it's concave down. And that's what we'll work on today, is those concepts. Okay? Concave up, concave down, and so on. So here it says, where is the first derivative negative and the second derivative negative? And you're going, how can I tell just by looking at the graph? Well, when the first derivative is negative, that's when the slope is downward. And where the second derivative is less than 0, that's where it's concave down. So you need to find where the slope is down. Well, the slope is down right here and right here. That's where the slope is negative. Okay? Now, where's the slope negative and it's concave down? Well, right here, it's concave up because the cup will fill up. Okay? You can put water in the cup, so it's concave up. Okay? When the water is pouring out of the cup, when it falls out of the cup, it's concave down. So it's concave down here. So it's from here on over. So it's where is here on over? Well, from 1 to 3, it works. So I would guess, whoops, this is the answer. Okay. Because negative 4.5 to negative 3, it's concave up, so that's why it wouldn't work. Negative 1.5 to 0, it's concave down, but the slope is up, so that's why it wouldn't work. But the 1 to 3 would work. Okay, so here we're looking where that is saying that the slope is what? Positive. And this is concave down. Okay? Slope is positive, concave down. Okay? Well, let's look at A. A goes from -4 to -3. The slope is positive. And is this cup pouring out or filling up? Pouring out. So it's concave down. So A would work. If we look at B, from 0 to 1, 0 to 1, it's concave down. And it's a positive slope. So 0 to 1 would also work. 4 to 4.5, 4 to 4.5, it's going up, and then it's part that's concave down. So all three of them would work. Okay? Because from here to here, it's concave down. From here to here, it's concave down. From here to here, it's concave down. Here's concave up. Here's concave up. Here's concave up. You get the concave up, concave down, pouring in, pouring out. Okay? So where would be a point of inflection? Where would it change from concave down to concave up? On this one, where would it change from concave down to concave up? Would A be a point of inflection? Because it's concave down here. What about here? It is. No, it's actually, if you would finish it out, it would be filling up. So A is a point of inflection. It changes there. It's filling up here, pouring out here. Is B a point of inflection? Yes. C, it's going from pouring out to filling up. C would be a point of inflection. Would D be a point of inflection? No, it would not be. It would be a minimum point. Okay? So those are all points of inflection. Would A be a point of inflection? Would A be a point of inflection? No. Would B? No. Would C? No. Would D? No. It's concave up the whole time. There's no points of inflection if it's concave up the whole time. So none of them would be. Okay? Any of these points of inflection? C would be a point of inflection because it changes from concave down to concave up. Now it asks, where is it concave up? Well, let's take two derivatives of this. The first derivative of this is negative 20x to the third plus 12x squared minus 20. The second derivative of this is negative 60x squared minus plus 24x. So if we factor out the greatest common factor, the greatest common factor is 6x, 12x, 12x. How about negative 12x? So then we get 5x plus minus 2. So x equals 0 and x equals 5 or 2/5. Okay, so if we put negative 1 into here, we get a positive here and a negative here. What's a positive times a negative? It's a negative. If we put in 1/5 into this, we get a negative here, and 5 times 1/5 is 1, minus 2 is a negative. What's a negative times a negative? Positive. If we put a 1 in here, we get a negative times a positive, which is a negative. Where is it concave up? Where our test points are positive. So it's in between 0 and 2/5. That's where it's concave up. Where's this concave down? Well, I don't want to take a couple derivatives of this if I don't have to. I'd rather just graph it on the graphing calculator and see. So I'm going to do that. So I'm going to look at -5 over parentheses x minus 2 parentheses graph. Okay, here is concave up. It's filling up. Here is concave down. Looks like we have an asymptote at where? 2. So it's where it's bigger than 2. Okay, it's where it's bigger than 2. Sometimes looking at the graph is faster than going through all this work. Okay. This is where it gets a little trickier. Okay? So if you're not paying attention now, pay attention to this. Okay. The number, this says the point -6, -1 is what we're looking at. That's the point. This says the slope. The slope is 0. What happens when the first derivative is equal to 0? It's either a min or a max. Okay? The second derivative is negative. That means it is concave down. When it's concave down, what will this be? It'll be a max. So 6, -1 is a maximum point. That's what this gobbledygook all says. But you got to go through it one thing at a time to figure out what's going on. Okay, let's do another one of those. We're talking about the point 6, 7. The first derivative is 0, so that means it's a min or a max. And the second derivative is 0, so that means it's a point of inflection. Okay? So what happens here is it's like this. So is that a min or a max right there? No. So there's not enough information to tell. We don't know if it's a min or a max, and we're pretty sure it's neither. Okay? It flattens out so it's horizontal right here for an instant. Okay? But then it continues to go up or it continues to go down. We can't tell. Okay? So that is that. I'm done teaching. You have an hour and a few minutes, an hour and 10 minutes or more to work on this and to eat cake and to have Rice Krispie bars and to have dirt and worms, and we all celebrate. And I'm sorry Ava is gone.